So in this lecture, we're going to spend some time talking about covalent bonds. And hopefully, from last time you remember, we talked about these things called ionic bonds. So in an ionic bond, it's one element stealing away electrons from another one. So let's take a look at our periodic table and see why that might happen. So you'll remember, hopefully, that ionic bonds take place between a metal, which is the stuff over on the left, and a nonmetal, which is the stuff over on the right. And again, you're not going to be required to remember specifically oh, chlorine's a nonmetal. But you should kind of know generally where the nonmetals are on the periodic table. They're over on the right-hand side. So let's just do sodium. Let's get it on the actual screen here. Do sodium fluoride, and if we consult our periodic table, sodium has got one valence electron, and fluorine has got 1, 2, 3, 4, 5, 6, 7. Okay, so again, we're making an ionic bond. Let's go back to full screen. So this atom is going to give its electron away, which is going to leave fluoride, an extra electron. Draw so you can see it. And that's going to mean it's going to have a negative charge. And our sodium now has lost an electron. So it now has a positive charge. Because these things are oppositely attracted, or oppositely charged, they're now going to be attracted to one another, and you're going to have a neutral molecule of sodium fluoride. The bond is happening between two non-metals. Is that hyphenated? I don't think it's hyphenated, but that's okay. Covalent bonds happen between two nonmetals. So let's go back to our periodic table. And so again, the nonmetals are all things over here. Let's grab one that maybe you've heard of. Let's go and build an O2. So oxygen's here. It's number 8. How many valence electrons does oxygen have? Well, if we count our groups, we have 1, 2, 3, 4, 5, 6 valence electrons. So let's put an oxygen here. Make our electrons a little bit more apparent. Okay, and so if we're following that octet rule, what is it that oxygen wants? Oxygen wants to fill up its outermost shell, right? So let's draw another oxygen here. I'm going to switch colors, but I don't think you can really see the colors on this. Maybe a little bit. Okay, so we have these two atoms of oxygen. They each want to fill up their outermost shell. So this covalent thing, covalent might give you a clue as to what's going to be happening here. Well, we have these two molecules of oxygen, and what they're going to do is they're going to wind up sharing electrons so that each of them feels like oxygen atoms don't feel, but each of them feels like it has a filled up outer shell. So there's our new electron diagrams. Okay, what's going to happen is these two electrons are going to be shared between these two molecules, these two atoms of oxygen. And when that happens, it's drawn like this. So how many electrons do we still have over here? We still have 1, 2, 3, 4, 5. Same over here, 1, 2, 3, 4, 5. But they're sharing this one. They're sharing that. And so each of them now feels like it has both of those electrons. So this oxygen now feels like it has 1, 2, 3, 4, 5. But now it feels like it has both. So we'll see a 6 and 7. This oxygen feels like it has 7 electrons. This oxygen feels like it has 1, 2, 3, 4, 5, 6, and 7 still applies for this one. Okay, so each of them now almost has a filled outer shell. Feels like it almost has an outer shell. So what do they have to do to get the rest of the way? Well, they're going to share this other electron. They're going to share this electron here. And again, when two atoms share an electron, you draw that as a line. So we'll get rid of this, and we'll just redraw that as our covalent bond line. And there it is. So each of these oxygens now feels like it has a filled outer shell. It feels like it's completing that octet rule. But what's really happening is these are just more chemically stable. Okay, each of these oxygen atoms is more chemically stable than when it had those extra valence electrons. Okay, so again, we're fulfilling the octet rule. Covalent bonds are drawn as a line. Okay, something you should know. And let's do a couple more. Ubiquitous molecule, we'll do H2O. You probably remember hydrogen has 1 valence electrons and oxygen has 6. You can cross-reference the periodic table, but we've got hydrogen here. It's 1 electron. We've got oxygen here. 2, 4, 5, 6, and we have another hydrogen here. It's 1 electron. So what we're going to do, or what these atoms are going to do, is these two are going to wind up getting shared, and these two are going to wind up getting shared. And so then you have oxygen here, covalently bonded to 2 hydrogens, and then it's got these extra, oops, I went off my screen, put it over here. Okay, so covalent bonds, let's do one more covalent bond, and let's see, what's a good covalent bond? We'll keep using hydrogen because hydrogen's pretty easy. And again, hydrogen is a non-metal. So we'll do CH4. Let's go back to the periodic table so we can look up carbon. So carbon's right here. Carbon has 1, 2, 3, 4 valence electrons, so we'll just put that here. So this is but this is a reason why carbon is the central molecule in so many different compounds, because carbon can easily bond with a lot of things because it has those 4 valence electrons. So again, hydrogen's got 1. We've got 4 of these hydrogens. Okay, so we're going to share these electrons, we're going to share these electrons, we're going to share these electrons. So the way you draw this is like this. Okay, CH4, 4 covalent bonds on carbon. Let's do ammonia, which is NH3. So let's look up nitrogen, see how many valence electrons we have. Nitrogen's over here, so we've got 1, 2, 3, 4, 5 valence electrons. Just go ahead and draw those. Nitrogen's got 1, 2, 3, 4, 5 valence electrons, and hydrogen has got 1. 1, 2, 3. Okay, cool. So this is a little sloppy, sorry, but it should be pretty obvious, hopefully, what's going to happen here. Nitrogen wants to get 3 more electrons, and hydrogen, all 3 of these hydrogens want to get rid of theirs. So we're going to share these, we're going to share these, we're going to share these, so that looks something like this. Okay, and again, nitrogen, forgot, there's an unpaired set of electrons here. Almost forgot those guys. So nitrogen now feels like it has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. Its octet rule is fulfilled. Nitrogen's happy. These hydrogens feel like they have two outer electrons now. Their octet rule is fulfilled, so they are happy as well.